In this lecture, we will enumerate all the maximal independent set. So that will be the topic. Okay. Before moving into the enumeration part, let me first define what is an independent set, and then we will move into the definition of the maximal independent set, and then we will list out the maximal independent set using the logic of Boolean arithmetic. Okay, so that will be the topic. So first I will define what is an independent set. A subset S of vertex set V. Okay, subset S of a vertex set V is called an independent set. Okay, it is called as an independent set if any two vertices in S are non-adjacent. Okay, so if I take any two vertices in S, they are non-adjacent, which means that if I take any two vertices in S, there is no common edge incident with those two vertices. That is called as an independent set. Now we have to define what is a maximal independent set. Okay, so now what I do is an independent set S is a maximal independent set. Okay, I call this as a maximal independent set if any superset of S, if any superset of S is not an independent set. Suppose if I take S and if I add an element to S, it should violate the independent condition. Such a set is called as the maximal independent set. Okay, it is different. This maximal is different from maximum. Okay, and independence number would be the maximum cardinality of a maximal independent set. Okay, let me also write down this. Independence number of a graph. Independence number of a graph. Okay, what is that independence number of a graph? Is the maximum cardinality. Okay, maximum cardinality of a maximal independent set. Okay, it has to be a maximum cardinality of a maximal independent set. Okay, so this is called as the independence number of a graph, and of course you would have seen that independence number and vertex covering number are complement to each other. When I add those two numbers, I will have the total number of vertices or the order of the graph G. So here you have defined what is an independent set and what is a maximal independent set. So now what I will do is I will just explain this using an example. Okay, let me take this simple example here. Okay, if I have like this, okay, this one would be A. Let me draw like this. Okay, I have like this A, B, C, D. Okay, next one would be E, F, and G. Okay. So now I take A, D, F. Okay. So A and D, I don't have an edge between A and D. Similarly, I don't have an edge between A and F. And D and F are also independent. I don't have an edge incident with both D and F. So this is one maximal independent set. So now I can have another maximal independent set, A, B, C, E and G. Okay, if you look at this, I have another set B, C, E and G. Okay, I don't have any edge incident with any two vertices here. And this is also a maximal independent set because I cannot include A to the second set. When I include A, that will be adjacent to both B and C. So the condition of independence is violated. If I add D or F, it is adjacent to E and G. So it violates the condition of independent set. So in this case, you have R. Okay, so now what do you get? R maximal independent set. Okay, so now if you look at this, the maximal independent set does not depend upon the cardinality. Okay, it is, as I told you, is different from maximum independent set. But of course, this could be a maximum independent set because here I have cardinality 3, here I have cardinality 4. So this could be a maximal independent set. So this is the difference between a general independent set and the maximum independent set. Say for example, if I take this vertex BC, vertex BCG, okay, this is an independent set. Okay, is an independent set. Is an independent set, but not maximal. Okay, why it is not a maximal? Because I can add another set. It's an independent set, but not a maximal independent set. So now what I can do is I can add E to this set, and BCEG is an independent set, so it cannot be a maximal independent set. So now what we will be doing here is we will be enumerating all the maximal independent set of a graph. Here I have given 2. Okay, I have still many more maximal independent set. Okay, here if you look at this BCF, okay, this is another maximal independent set. So I have given you 3, but let us see what are all the maximal independent set of a graph. You can, when I find the maximal independent set of this graph using the same technique, you can find the maximal independent set of any general graph. Okay, so that would be the next part. Okay, so now what I do is I write the enumeration part here. Okay, let me write like this: enumerating. Okay, enumerating all maximal, okay, independent sets. As I told you, we will be using the Boolean arithmetic. Okay, Boolean arithmetic is used. But now let us express how to represent the graph using the Boolean arithmetic techniques. Okay, so now what we do is let like this. Let each vertex in the graph G, each vertex in the graph G is represented as a Boolean variable. Okay, so this will be the first part. Okay, as a Boolean variable. Okay, and now what I will do is the second part. Let the logical sum, okay, logical sum A plus B include, okay, include A or B or both A and B. Okay, so this will be the notation. When I write A plus B, it would include vertex A, vertex B, or both vertex A and B. Okay. Now I will take the third representation. Let the logical product, AB, okay, include both A and B. Okay, let them include both A and B. Of course, vertices. Okay, all these are all vertices. It will include all the vertices AB. Okay, so now I will also introduce another one. Let the Boolean complement. Okay, because I will be using this also. Boolean complement A dash, okay, A dash denote, okay, that vertex A is not included. Vertex A is not included. Okay, so now you have like this. So what I do is I write the sum. Okay, I write the sum A plus B to include vertex A, vertex B, or both vertex A and B. Okay, similarly, here when I take the product, I include both the vertices A and B. And now if I write the complement A dash, which means that the vertex A is not included. Okay, so now what we will do is I will just give you the steps how to find maximal independent set. Maximal independent set. Okay, so now let me write like this: maximal independent set. Okay, so now what we do is we express, okay, each edge. We will express each edge x comma y as a Boolean product. Okay, Boolean product xy. Okay, when I write xy, I mean that I take an edge xy. Okay, so now what I do is I represent phi as summation xy. Okay, where x comma y belongs to E. I take the sum of all the edges. Okay, and now what I do is I take the complement of phi dash. Okay, sorry, complement of phi. Okay, complement of phi, not phi dash. So your phi dash will be something like this: f1 plus f2, okay, plus so on fk, okay, plus so on fk. Okay, so now you will have like this. Okay, now what I do is I have like this a vertex set. Okay, it is like this: a vertex set is a maximal, okay, is a maximal independent set. Okay, it will be a maximal independent set if and only if phi is equal to 0, because you should not have both the vertices x and y in this independent set. So it has to happen, this is phi has to be 0. Okay, this is possible. When this is possible, okay, this is possible. Okay, what do you have? If and only if this is possible only when phi dash is equal to 1. Okay, this should have value 1. Okay, then only you will have phi to be 0. Okay, but if this has to be 1, phi dash has to be 1. Okay, what will happen? This I have like this. This is possible. Okay, when this is possible, if and only if at least one fi is 1. Okay, you should have at least one fi is to be 1. Okay, when this is possible, okay, again let me write like this: this is possible. Okay, this is possible if and only if each vertex each vertex appearing in Fi, okay, each vertex appearing in Fi is excluded, okay, is excluded from the vertex set, from the vertex set of G, from the vertex set of G. So all these are all just like a chain. Okay, phi will be 0. This can happen only when phi dash is equal to 1. And when phi is equal to 0, we mean that the set is an independent, maximal independent set. And when this is equal to 1, then you have expressed this phi dash in terms of sum of some variables, and at least one term in the variable has to be 1. And if this has to be, if each term has to be 1, then this is possible that each vertex appearing in the Fi has to be eliminated or excluded from the vertex set G. Okay, so now what happens here is that when you do like this, then you have this each Fi. This implies that each Fi, okay, will yield, each Fi will yield a maximal, independent set. Will yield a maximal independent set. Okay, so this can be used. Okay, so you will have like this. This technique can be used to enumerate the maximal independent set. Okay, let me explain this, what we have done here, for the example that I have given here. Okay, let me write like this. This will be A, B, this one is C, D, I'll write E, F and G. Okay, so now what I have to do is, I have to find or enumerate the maximal independent set. And before moving into this, I will write this one we will be using quite often. A plus A is equal to A is equal to A plus AB is also A. We will be using these three quite often. So now what I do is, I write down the edges here. AB plus AC plus CD plus BD plus DE plus DG plus EF plus FG. Okay, so now I have 4 plus 4, 8 edges, which are expressed as a Boolean expression here. 1, 2, 3, 4, 5, 6, 7, 8. AB plus AC plus CD plus BD plus DE plus DG plus EF plus FG. So now what I do is, I calculate phi dash. This would be A dash plus B dash multiplied by A dash plus C dash multiplied by C dash plus D dash multiplied by B dash plus D dash. Okay, let me write this separately. And then I have multiplied by D dash plus E dash and D dash plus G dash, E dash plus F dash and F dash plus G dash. Okay, so now what I will do is, I will multiply the first two. I will have A dash plus A dash B dash plus A dash C dash plus B dash C dash. Okay, so I will multiply the first two. Now I will multiply third and fourth one. C dash B dash plus D dash B dash. Okay, sorry, I have written like the C dash B dash, yeah, D dash B dash, and the next one would be C dash D dash plus D dash. Okay, and then I will multiply the next two, D dash D dash. Okay, let me write here also all the terms, D dash D dash. Okay, D dash D dash, D dash D dash plus D dash E dash plus D dash G dash plus E dash G dash, and then the last two, E dash F dash plus F dash F dash plus E dash G dash plus F dash G dash. So now I have got the product of two terms and I have written here. Okay, now let me simplify this. I will have A dash plus A dash B dash plus A dash C dash plus B dash C dash. This would be C dash B dash plus D dash B dash plus C dash D dash plus D dash. Okay, and for the third one I'll have D dash plus D dash E dash plus D dash G dash plus E dash G dash. And similarly for the last term I'll have E dash F dash, product of F dash and F dash is F dash plus E dash G dash plus F dash G dash. Okay, if you look at this, I've used the second one. A is equal to A. That is D dash will give you D dash. So now what I will do is, I will use this A plus AB is equal to A, and this would give you A dash plus A dash B dash would give you A dash plus A dash C dash will give you A dash. Okay, I'll just write down here this. Okay, this would give you like this. Okay, A dash plus A dash B dash is equal to A dash, and A dash plus A dash C dash is equal to A dash. Okay, so I have striked out these two. Similarly here I have D dash, C dash D dash will go, D dash B dash will also go. Here I have D dash E dash gets eliminated, D dash G dash also gets eliminated, and here I have F dash, so E dash F dash and F dash G dash gets eliminated. So I have the term A dash plus B dash C dash multiplied by D dash plus C dash B dash multiplied by D dash plus E dash G dash multiplied by F dash plus E dash G dash. So now what I have to do is, I have to just rewrite this. Okay, rewrite this in terms of, I have to just rewrite this in terms of sum of some Boolean expressions. So now what I will do is, I will again write down this. Okay, I'll just write down this in the next slide. A dash plus B dash C dash. Okay, so I have phi dash is equal to A dash plus B dash C dash multiplied by, okay, D dash plus C dash B dash. Okay, I have like this, D dash plus C dash B dash multiplied by, okay, so now what do I get? D E G and then F E G, D E G. F dash plus E dash G dash. Okay, so now I have like this. Okay, D dash plus E dash G dash, F dash plus E dash G dash. So now what I will do is, I will just simplify the first two terms. A dash D dash plus B dash C dash D dash plus A dash C dash, A dash B dash C dash plus B dash C dash. Okay, this is again A, B. Now I will multiply the last two, D dash F dash plus E dash F dash G dash plus D dash E dash G dash plus E dash G dash. Okay, so now when I take this BC, okay, then BC B dash C dash plus A dash B dash C dash will give you B dash C dash. Okay, this rule A plus AB is equal to A. Okay, similarly, if you use this color, I'll change this color to know better. Okay, I can remove this. Similarly, I have B dash C dash, this can be removed, and when I look at this, I have EG, so this will go, and here also I have EG, so this can also be removed. So this gets simplified to A dash D dash plus B dash C dash, and this is D dash F dash plus E dash G dash. Okay, so now what I will do is I will still simplify this. I have A dash D dash is D dash F dash plus B dash C dash D dash F dash. Okay, this would be A dash D dash E dash G dash. Then this would be B dash C dash E dash G dash. Okay, so now I have 4 terms. Okay, A dash D dash F dash, B dash C dash D dash F dash, A dash D dash E dash G dash, and B dash C dash E dash G dash. So now what I will do is I will exclude from the vertex set. Okay, write like this. Exclude from the vertex set. Okay, exclude from the vertex set. Okay, of G vertices appearing in any one of the 4 terms. Any one of the 4 terms, we get a maximal independence. We get a maximal independent set. Okay, we get a maximal independent set. Okay, so now if you look at this, here I have A. Okay, I have to omit it, and let me draw this graph here. It will be more better, okay, for our understanding. So I have taken the graph like this. Okay, this was A, B, C, D, E, F, and G. Okay, so now I have A, I have to remove it. So B, C, E, G. Okay, B, C, E, G is one maximal independent set. And when I take the second term, A is not there, A dash is not there, so I take A. B, C, D is present, E and G is not present. So I have A, E, G as another maximal independent set. And now when I take the third term, I don't have B dash in the third term, so I take B to be a part of the independent set, which is maximal. So I'll have B, C, and F. Okay, and the third, and sorry, not third, last one. Okay, last one would be A. Okay, so I have A, D, F. Okay, A, D, F are maximal independent set. Okay, so these are the maximal independent set. Okay, maximal independent set for this given graph. You can check here B, okay, C, E, G. Okay, and I had given another A. Okay, let me write like this: A, E, G. Okay, A, E, G is there. Similarly, I can have B, C, F. B, C, F is also there. And then I have A, D, F. So these are all the maximal independent set for this particular graph. So the main aim for this graph, main aim for this method is this. What we do is we calculate the sum of the edges. Okay, so I take phi is equal to xy, then from that I calculate or express phi dash as a summation of fi's. Okay, and by argument phi has to be 0, phi dash has to be 1. If phi dash has to be 1, then at least one term in the complement should be non-zero. If I have to have at least one to be non-zero, then I have to exclude that vertex appearing in the term so that I get a maximal independent set. So this method gives you an elaborate way of finding out the maximal independent set using, say we have used the simple arithmetic operations. A plus A is equal to A dash, sorry, A plus A is equal to A is equal to A, and A plus AB is equal to A. So I have used these three elementary operations in Boolean algebra, and I have represented the graph as a Boolean expression, and I am able to prove that or enumerate all the independent set which are maximal for the given graph. So this completes the solution of this particular problem. Now, as an application to this, okay, I'll just give you a problem 1, and I will also prove it. Okay, what is this problem? This will be given in terms of the communication network. Okay, each of the 7 vertices. Okay, you have like this, each of the 7 vertices. Okay, 7 vertices of the graph. Okay, so this is the 7 vertices of the graph is a possible code word. Okay, this will be a possible code word. See, this is given in terms of some words to be used in communication. Okay, so now I use this in a communication. So what I do is I draw a communication graph. Okay, so in the communication, some words, okay, some words are having same sound. Okay, are having same sound. Okay, so it will be difficult for us to identify those words. Okay, so it will be having same sound or close to other words. It will be close to other words. Okay, so what happens is it is having the same sound, so that they might be confused. They might be confused for each other. Okay, confused for each other words. Okay, pairs of words. Okay, pairs of words which are pairs of words which are to be mistaken, are joined by edges, okay, these are joined by the edges. Find the, okay, so now what I have to do is I have to find the largest code. Okay, I have to find the largest code, okay, words. Okay, I have to find the largest code words so that the receiver do not mistake the original message. You have to find the largest code words for a reliable communication. So for this communication, I have to find a largest code word. Okay, so finding out the largest code word is same as finding, what is that? Finding maximal. Okay, that will be this, finding maximal independent set. So for finding out the maximal independent set, they have incorporated and communication network, and they have like this. So now let me write like this. The graph that was given to us is this. Okay, so I have like this. This would be B, C, I have D here F3, then F at the top, and G. Okay, so now how many edges I have? 1, 2, 3, 4, 5, 6, 7, 8, 9 edges are there. So now what I have to do is I have to find a maximal independent set, or I have to enumerate all the independent set. So that will be the problem. Okay, so now what I will do is I will represent, let me draw this graph first here. so that when we write down the edges it will be useful for us. Okay, I'll take like this: A, B, C, D, E, F and G. Okay, so what would be your 5? 5 would be AB plus BC plus BD plus BE plus CE plus DE plus EF plus EG plus FG. Okay, let me see that I have 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 edges. Okay, 1, this would give you 4, this would give you 1, 2, 3, 4, 8, this one is 9. So I have 9 edges. Now let me write down what is phi dash. Phi dash would be A dash plus B dash, then B dash plus C dash, B dash plus D dash, B dash plus E dash, then C dash plus E dash, D dash plus E dash, then E dash plus F dash, and the next one would be E dash plus G dash, and this will be F dash plus G dash. I'll multiply these two. Okay, A dash B dash plus B dash, B dash B dash is B dash, plus A dash C dash plus B dash C dash. I multiplied these two. Similarly, I'll multiply these two. I'll have B dash plus B dash D dash plus B dash E dash plus D dash E dash. Okay, then I'll multiply these two. Okay, I'll have C dash D dash plus D dash E dash plus C dash E dash plus E dash. Okay, then I'll retain this E dash F dash as such, and then I'll multiply these two. Okay, when I multiply these two, I'll have E dash C dash. Okay, what do I get? E dash F dash plus E dash, sorry, E dash G dash plus G dash F dash plus G dash. Okay, so now let me take different color. So the B dash plus A dash B dash, I'll have B dash plus B dash C dash will give you B dash. So these two will go. Similarly here B dash plus B dash D dash, I'll have B dash plus B dash E dash is again B dash. Here I have E dash, D dash E dash plus E dash is E dash, C dash E dash plus E dash is again E dash. Now this I have G dash plus G dash F dash is G dash, G dash plus E dash G dash is G dash. So I have reduced the terms as such. Okay, now let me again write down the remaining terms. I have B dash plus A dash C dash. Okay, and the second term would give you B dash plus D dash E dash. The third term would give you E dash plus C dash D dash. Fourth one would give you E dash plus F dash. Last one would give you G dash plus E dash F dash. Okay, so now what I will do is I will multiply one after the other. Okay, let me call this as equation A. Okay, let me simplify this first two, then I will simplify the last two. Okay, and then we will add one after the other. Okay, so now B dash plus A dash C dash. Okay, consider B dash plus A dash C dash multiplied by, what is the next term? B dash plus D dash E dash. B dash plus D dash E dash. Okay, so now what I will do is I will write this B dash plus A dash B dash C dash plus B dash D dash E dash plus A dash C dash D dash E dash. Okay, so now when I take okay, you can see this. When I take this A dash C dash as some other term X dash, I'll have B dash plus B dash X dash, so that would get rid of this A dash B dash C dash when I add with B dash. And similarly I can also have B dash plus B dash D dash E dash as B dash. So this reduces to B dash plus A dash C dash D dash E dash. Okay, so you have to remember this. You have like this: B dash plus A dash C dash into B dash plus D dash E dash is this. Okay, you remember this. Now what I will do is, okay, I'll just take the next two terms. Oh, no problem. Either I can take these two or last two. Okay, let me take this: E dash plus C dash D dash and then E dash plus F dash. Okay, so now what do I get? E dash plus C dash, E dash plus C dash D dash. Next one was E dash plus F dash. Now what I do is I consider this. Okay, let me check whether I have written it right. E dash plus C dash D dash, E dash plus F dash. Okay, so now let me multiply this. I'll have E dash plus E dash C dash D dash plus E dash F dash plus F dash C dash D dash. Okay, as usual, when I take this E dash F dash with E dash, this will go E dash C dash D dash with E, that will also give you E dash. So I have E dash plus F dash C dash D dash. Okay, so I'll call this as 1. I'll call this as 2 because I think I have called this as A. Okay, previous one I have named it as A. Okay, so now what I will do is I will consider, okay, the product. What is this? B dash plus A dash C dash into B dash plus D dash E dash. This would give you E dash plus E dash plus C dash D dash into E dash plus F dash. This would give you the two terms B dash plus A dash C dash D dash E dash, and this gives you E dash plus F dash C dash D dash. Now I'll multiply these two. I'll have four terms: B dash E dash plus A dash C dash D dash, E dash E dash is E dash, so I have this. Now I'll multiply this with F dash C dash D dash with the B dash, so I have B dash F dash C dash D dash, and then this would give you A dash C dash D dash F dash E dash. Okay, so C dash will give you C dash once, D dash will give you D dash once, so I have A F E as the remaining terms. So now what I have to do is, again I will simplify this. Okay, here I have BE. Okay, I have to see whether I have the common terms here. Here if you look at this, I have this term. Okay, what is that? Look at this. I have A dash C dash D dash F dash E dash. Now here I have A dash C dash D dash E dash. Okay, so now the difference is between these two terms is the fourth term contains F. So when I use this rule, A plus AB is equal to A. When I take A dash C dash D dash E dash as A, so this would this can be removed. So this gets reduced to three terms. What I call it as equation 3. Okay, what I call it as equation 3. So now what I will do is, okay, substituting 3 in equation A, Okay, so now what do you get? We get, okay, phi dash is equal to, let me write down the terms that is present here. B dash E dash, okay, I have this B dash E dash plus, okay, what is the next term? A dash C dash D dash E dash, A dash C dash D dash E dash plus, and then the next term B F C D, okay, B F C dash D dash, B F C D plus, okay, no, that's all three terms, okay, and I have to multiply this with G dash E dash F dash, G dash E dash F dash, G dash plus E dash F dash, okay, because you could see here that I had taken these two, this term was left out, so I have to multiply. See, if you look at this, I have taken 1 year, 3 year, 2 year, and when I combine these two I get 3, so I have the 4 terms. So the last term I have not included here, so I have multiplied this. Again I have to use the same operation and simplify this. I'll have B dash E dash G dash plus A dash C dash D dash E dash G dash, and this would be B dash F dash C dash D dash G dash, and this would give you plus B dash E dash F dash, B E dash E dash will give you E dash, and the next term will give you A dash C dash D dash E dash F dash. Good. And the last term would be B dash F dash C dash D dash E dash, F dash is F dash, so I have written it once. Okay, so now what I have to do is I have to see that can I simplify this. Okay, so what do you get? BEG. Okay, so now you have to look at this, whether you have any terms so that you can simplify this. BEG, see, if you look at this, BEG, I have BEF, here B is missing, BEG is not here, good, BF is there, E is not there, B and G is there, E is not there, here I have EG, so B, so this will be an independent term. A C D E G, A C D E G, A C D E is there, but there is a difference. F and G is here, and similarly B E F, B F is there, E is missing. Here I have E alone, no problem. B F is there. Yeah. If you look at this, here I have B F E. Okay, so when I take this B F E. Okay, right like this. When I take this BFE as some x dash, so I'll have x dash plus b dash, so I can get rid of this. Okay, so here I have this. Similarly, here I have BES. Okay, so your maximal independent set would be, okay, maximal independent set for the graph is maximal independent set for the given graph is, okay, graph is, so now I have like this, A is not there, okay, B is there, C, D is not there, E is there, F is not there. So the corresponding to the first term I have A, C, D, F, and then the second one I don't have B dash, so I have A, B, C, D, E, F, that one is missing. B dash and F dash is missing, so I have written here. For the third one, A is there, B, C, D, E is missing, so I have A, E. And for the fourth one, A is missing, C, D, E, F, G, A, C, D, G. Good. And for the last term here, 1, 2, 3, 4, fifth term, here I have A is there, B dash is not there, so I include B in the set, C, D, E, F, G. Okay. So now I have these 5 as the maximal independent set, for the given graph here. So what happens here is that we can also check this by drawing this graph again. Okay, but of course this would give you the same result. A, this one was B, C, D, E, F and G. Okay, I have to label the vertices as I had done before, B, C, D, E, F, G. Okay, so that is important. B, C, D, E, F, G. Okay, now you can see that A, C, D, F. Okay, A, C, D, F is one independent set, and the other independent set is B, F. So when I include B, then I cannot include A, C, E or D. So out of these two, F and G, I have to include one. So I have included F here. Similarly, when I include A, okay, when I include A, I cannot include B. And when I include E, then automatically I cannot include C, D, F or G. So A, C, D, G is also and maximal independent set. Then I have B and G as another independent set. So this particular graph has got 5 maximal independent sets. Okay, so this completes this particular problem, and these are the largest code words which could not confuse the receiver in a communication network. So this completes the solution of this particular problem. And let me recall what we had done in this lecture. We had defined what is a maximal independent set. Okay, we had defined what is a maximal independent set, and then we had used the Boolean arithmetic. Okay, Boolean arithmetic to enumerate maximal independent set. Okay, so I have used the Boolean arithmetic to enumerate maximal independent set. Okay, and I had used these 3 important Boolean rule: A plus AB is equal to A plus A is equal to A, and product of A is A. And these 3 rules were used to simplify the given Boolean expression. And the gap between these two is that we had also discussed how to represent a graph. Okay, how to represent a graph as a Boolean expression. Okay, so Boolean expression. So once when you can do all these, you can easily enumerate all the maximal independent set of a given graph. Okay, so this completes this particular lecture, and if you have any doubts, you can mail to this email. I will be answering your queries. Okay, max.sastra.edu. Okay, and I will be answering your queries. Thank you.